So here we are with chapter 12, section 1 on reflections. Reflections are some of the easiest ones to be able to figure out. Do you remember from when you were younger and you learned symmetry? Symmetry means that one side matches the other. For instance, when you were younger, you did lines of symmetry. You could draw a line right down the middle, and you could see, one second, that the other side matched. So if you drew it down this way, the left side is the same as the right side. If you drew a line of symmetry down this way, you can see that the top side matches the bottom side. Okay, and that's basically what we need to know for reflections. For a triangle, you could draw a line right down the middle, and this side matches this side. But that's not the only one. This is an equilateral triangle, meaning all sides are equal, so you could draw up the middle this way, and these two sides would match, etc. And there's a third line you could draw going this way, cutting in half. A circle has an infinite number of symmetrical lines of symmetry, because anywhere you cut a circle down the middle, it's going to be symmetrical on the other side. You could draw any number of lines you wanted to going right down the middle. But when you have a hexagon with 6 sides and it's equilateral, you can make 6 lines. You can make one like this. It cuts this side in half with this side. You could also draw one going down this way, and the left-hand side matches the right-hand side. Everywhere there's a vertex, you could draw a line of symmetry like this. And everywhere there's a side, you could go right down the midpoint, and you could draw a line of symmetry. So if you add that all up, there's a total of 6 lines there. 1, 2, 3, 4, 5, 6. But when you look at something like this that's unique, there's only one line of symmetry that you can draw. It's not like a circle where it's all the same on the inside. There's 2 eyes that have to match and a mouth. And so you can only draw it straight down the middle here. That's the only way that it can be symmetrical on the left and the right. So just look at this example really quickly, and then we'll get to your notes. To reflect something, it's like looking in the mirror. It looks the exact same as you look. However, when you move your right hand in the mirror, it's the left hand that's moving. So it's the same, but it's just flipped completely around. So let's imagine that we're going to reflect in the x-axis. The horizontal line is the x-axis. We need to have a line of symmetry, and that is going to be considered the mirror. This x-axis right here is like our mirror, and this trapezoid is going to be reflected through that. So what you do is you imagine it on the other side, but turned around, backwards, like you would look in a mirror. So all you do is imagine it on this side. So this is flipped through the x-axis. Please notice that this point is 2 points up from the line of symmetry or the mirror here. And on the other side, it's exactly 2 points down, up, then down. And the O is 2 points up. So the image has to be 2 points down, exact opposite. The N is 4 points up. So over here, we had to go 1, 2, 3, 4 points down to make it match. Likewise, if you're going to reflect through the y-axis, you need to have your line of symmetry or your quote-unquote mirror. You had to have that in your mind first. In this case, it's the y-axis. So this time, I'm not going to flip it upwards. I'm going to flip it across over here. But it has to flip. It has to turn around and be the exact opposite, just like it would be in the mirror. Now think about this for a second. I'm going to place this in the right place. But look, this point is exactly 1 point to the left. So I need to make sure that on the other side, I do the exact opposite and go 1 point on the right there. This one is 1, 2, 3, 4 points to the left, so I made sure I went 1, 2, 3, 4 points to the right, etc. So this is what it looks like when you flip it or reflect it in the y-axis. So we're going to go through some practice boards tomorrow in class. Tonight, don't forget to fill in your keywords from page 824 for isometry, and fill in the shaded box word for word along with the drawings so you can get full points when you turn in your test booklets. And here are our practice problems. There's two ways to do it, and I know some of you want to do it with formulas and some of you want to do it visually, so I'm going to show you both. When you're going to reflect in the x-axis, there is a simple rule you can follow every time. Reflecting in the x-axis takes any point you have already, x comma y, and turns it into x comma negative y. The x's stay the same, the y turns into negative y. So go ahead and graph these 3 points. You can pause if you need to do that. I already did it and I'm going to place them in the right places, but go ahead and pause and mark these as necessary and then hit play again. We're going to start with A right here at negative 1, 2. That's my x and my y. The A here becomes, or it already is, 1 comma 2. Now I have to create a new image out of that, and I have to call it A prime. To do that, all I'm going to do is follow the rule. X, which is 1, stays x. So I'm going to keep it as 1. But the y, which is 2, has to turn into negative y. So that is going to turn into negative 2. And that's a new point that I have. So all I have to do now is go down here and mark my point at negative 1 comma negative 2 this time. I go to the left 1 and I go down 2. Make that a little bit further over. There we go. All right, so now I've got my A. Notice that A is above going 2 spots, and A prime is going to be down going 2 spots. So it's exactly mirrored on the opposite side of the x-axis, which is going to be eventually acting as our mirror. Now let's try the same thing with B. B starts out at negative 3, 4, negative 3, 4 here. So B, which was negative 3, 4 to begin with, turns into B prime. And we have to follow the rules. X is negative 3, and in our result, X stays the same, negative 3. But the Y, which is 4, turns into negative Y, which would become negative 4. And that's where our new result, our image, comes from. B prime is going to be over here at negative 3, 1, 2, 3, 1, 2, 3, 4. Negative 4 right here. And that is going to be B prime. B prime. And then we do the same thing for the C. C is up here. Oh, by the way, notice the B is 1, 2, 3, 4 up from the x-axis, and the B prime is 1, 2, 3, 4 down from the x-axis. It's the exact opposite. The last thing we need to do is C at negative 1, 5. That's where it starts. So we have C is at negative 1, comma 5, and it has to turn into C prime. The x stays as negative 1, and the y at 5 turns into negative y, which would become negative 5. And so we graph the point negative 1, negative 5. Negative 1, negative 5 is right about there, and we're going to call that C prime. Okay, so all we need to do now is connect our new image right here, and look at how that's the reflection. See this right here? It's said to reflect in the x-axis. That means that the x-axis was supposed to be our mirror, and if you look at it, it turned out that way. Because here's our mirror. A is 2 points up, A prime is 2 points down. B is 4 points up, B prime is 4 points down. C is 5 points up, and C prime is 5 points down. So no matter which way you do it, using this rule, or just by making it match onto the other side and flipping it, either way, the reflection is pretty easy to figure out. All right, let's do the next one over and the next screen. Hold on one second. I'll try to do something here and then it will tell me to escape. There we go. Escape, save, close. All right, so now we're on our next example here. This one says to reflect in the y-axis. So let's keep that in mind as we're doing it. We're going to be reflecting in the y-axis. So it's this second rule right here. Reflect in the y-axis, and the rule for reflecting in the y-axis is right here. Now again, you can do it any way you want, but I'm going to show you both ways so that you can see that it works. Let me maybe go backwards this time. Okay, here's the y-axis. So I need to highlight that so that I know what axis I'm looking at. So let me do that in green. Here's the y-axis. This is our mirror, or our line of reflection. And we're going to make it match on the other side. However far it is on the left, we're going to make it go on the same distance on the right. And then we're going to look at the rule to see how that would have turned out the same. Okay, so we start with A at -1, 2. If you look at it here, it's 1 to the left, so we're going to go 1 to the right. And we're going to call that A prime. That's our new point. Look at the B. The B goes exactly 1, 2, 3 points to the left, so we're going to have to go exactly 1, 2, 3 points to the right, and we'll call that our B prime. And up here at the C, it's exactly 1 point to the left, so we're going to go exactly 1 point to the right, the opposite. And we're going to call that C prime, and then we can connect them and see what our new image would look like. And there it is. You can see that it's exactly flipped on the other side and it matches perfectly. But some of you like to be able to do it by algebra, so let me show you the way you could do it with the rules as well. This one was A prime, B prime, and C prime. Our images always have the little apostrophe, which stands for prime. So for the rule, I'm going to first of all take my point A, which started out at -1, 2. I'm going to follow my rule and see how the A prime came about. X stayed the same. I'm sorry, X is -1, but this time the X turns into -X. So I have to take this -1 and make it the opposite, so it's going to turn into +1. X turns into the opposite of X. But if you look at the rule, the Y, which is 2, stays Y. It doesn't change. The Y becomes just another Y, so that is 2, and that's what our new point should be. Look, it worked. A prime is at 1, 2. Okay, to figure out what B would be, you can just see how the rule works. The B started out at -3, 4, and B prime turned into, or should turn into, the X should turn into -X. So -3 is going to become +3, but the Y stays the same. Y stays Y, so we just turn it into +4. And then we have B prime here at 1, 2, 3, 1, 2, 3, 4. So either way you choose to do it, it works. And the C at -1, 5 would turn into C prime, where the X stays as it is. No, I'm sorry, the X changes. X, which is -1, turns into the opposite of X, which is +1. And this time it's the Y that stays the same. So we're at the point -1, 5, which you see for C prime is 1, it's 1, +5 right there. So you have a reflection that's exactly the same shape, but flipped around on the other side of the mirror. And the last one you need to be able to do is this one right here. Save. And now we're going to look at reflecting it in the line y equals x. And this is the trickiest for people because sometimes you forget your algebra. But y equals x is just in the form y equals mx plus b. So we have to graph that line as our mirror. And we're going to be thinking about it as y equals mx plus b. So my slope is 1. And my y-intercept is 0. If you think about it as mx plus b. So I start at my 0. Here's my y-intercept, up 1, right 1, up 1, right 1, up 1, right 1, etc. And that's what my mirror is going to look like. It goes at a slope of 1 all the way across. Now the mirror has to match on the other side, and again, there's always two ways of doing it. You can use the rule which as you see here, the xy just turns into yx. The positives and negatives stay the same, it just flips around. Or you could imagine it on the picture itself. So do it, go ahead and hit pause right now, do it whichever way you want, whichever way you're used to now, and then come back and check it. I'm going to start off by doing it with the rule. So my A started out as -1, 2, and following the rule, A prime becomes, you just flip it around, yx. So my y goes to the front now, and my x goes to the back, -2, 1. Then I have the point B. Well, I'm going to go ahead and graph that. -2, 1. When you go to graph it at -2, I'm sorry, +2, -1, it goes right here. Notice it's still straight across, straight through that mirror, just on the opposite side. But this time it went 1.5 boxes away on the top side. So it has to go 1.5 boxes away on the bottom side, just straight through. So if you like doing it visually, then you can work it out that way as well. It started out as -3, 4. When I follow my rule, B prime becomes just the same thing but flipped around, 4, -3. So to graph that, I go here to 4, -3. And this was my A prime and this was my B prime. And for C, it starts out at -1, 5 and it's going to turn into C prime. This just turns around, it's 5, -1. All the positives and negatives stay the same. So the C is right here at 1, 2, 3, 4, 5, -1. Right there. And go ahead and I'm going to draw it here. This one's C prime, and my drawing, my new image looks like this. Now, it's a little bit harder to do when it's on a diagonal line, but if you notice, these still go straight across. Look at this, count this straight to the green mirror, 1, 2, 3. The C prime still goes 3 straight through on the other side, 1, 2, 3. So whichever way you choose it is fine. Just make sure you're choosing one that works for you.